Good morning. This is Tech Talk, and I'm Jim Brewer. And today's topic is electrical safety. So, the first thing we need to know about electricity is it's invisible. Um, it's a hidden, invisible, dangerous hazard. Um, Electricity is certainly an important thing in our lives. We couldn't watch TV without it. We couldn't get on the internet without it. There's a whole lot of things we couldn't do without electricity. But if it's not managed properly, it can certainly be a hazard. Lots of workers are electrocuted each year due to the improper use of electrical cords and tools. So electrocution can be the first event in a chain of events that leads to serious injuries, such as electrical burns or falls. Um, those are the two most common. You get electrocuted, you fall, and then you get injuries from the fall that may be worse than the electrocution. This picture shows an electrical burn on this fella's hand, um, and there are lots of gruesome pictures on the internet. If you Google electrical burn injuries, stuff that looks far worse than this, but even this is bad enough. That injury could cause permanent paralysis in those fingers because it damages nerves and muscle. Um, and that could be the entrance wound for other internal electrical damage. The worst type of electrical shock is when you take both hands contact the electrical energy source, then that electricity tends to run across your arms, or up your arms and across your chest, right across your heart. That's the type of injury that is likely to cause problems with your heart, possibly even stopping your heart. Fall injuries may begin because of an electrical shock. You're doing some work on a ladder, and that ladder becomes energized in some form or fashion. That could be a bad spot on your extension cord gets dragged across the ladder frame. It could be the ladder comes in contact with some power lines, something like that. You fall off the ladder, or most appropriately or most accurately, you're knocked off the ladder by the electrical shock. That can lead to broken bones, head injuries, paralysis. Uh, any number of injuries could initiate as a result of that electrical shock. Be particularly careful with ladders and scaffolding. These are primarily metal and they will conduct electricity. So before you begin setting up your ladders or scaffolding, do a job site walk around so that you know where all of the electrical hazards are. Uh, the standard safety recommendation is at least a 10-foot separation between your ladders, scaffolding, and electrical wires. Personally, I like to see a much larger safety zone. If you're extending a 32-foot ladder, I would like to see that 32 feet from an electrical hazard. Um, it's human nature to try to save the ladder. If the ladder starts to teeter or fall, you're struggling trying to keep it from falling. But if it continues to fall and you're holding on to it when it contacts the power lines, well, that's a bad day. Fiberglass ladders can be a little safer in this regard because they don't conduct electricity. And fiberglass ladders may be required on some work sites. Last summer, we were doing a commercial fireplace installation on a project, and the contractor superintendent wouldn't allow any ladders except fiberglass ladders on the work site, whether they were extension ladders or step ladders. We had to have fiberglass ladders on that work site. I recommend that you carry your ladders horizontally rather than vertically to reduce the likelihood of contacting overhead power lines. It's one of my personal pet peeves to see a technician walking with the ladder in a vertical fashion. That could, easily cause you to lose your balance and trip and fall. And certainly it increases the likelihood of getting that ladder caught in some power lines. And that would just be a really bad day. So please carry your ladders horizontally rather than vertically. This fellow in this picture is doing it properly. Extension cords are important on any job site. Often we're working up on the roof. We need to, run a drill or a grinder or something up on the roof. We got to be able to get the power up there. So make sure your cord is free of damage and properly rated for the job. You can see in this picture there's a huge variety of extension cords, different diameters or thicknesses, different lengths. The thicker cords will provide the power you need over greater distance. Look at your tools and equipment that you're going to be using, know what the power requirements for those tools are, and select an appropriate extension cord. All right. Make sure that your extension cords are free of damage. You can see in these pictures some different damage. Over here on the right, the black cord is missing the ground prong. Right off the bat, that cord should be taken out of service. The orange cord, top middle, the wires are coming out of the plug there. That's a problem. The red cord in the bottom photo is actually cut and exposing the neutral wire there. That's an immediate electrocution hazard. If you touch it, you're going to get shocked. If it rubs up against your ladder, you're going to get shocked. So any of those cords you see in that picture there should be immediately taken out of service and either destroyed or repaired. Some people are under the impression that you can't repair these things, but actually OSHA does allow cords to be repaired if you use a proper fitting. Make sure you're using the proper type of plug. Anything outdoors should be a grounded 3-prong plug, and under the OSHA construction rules, that's actually required on job sites.
Hey, Jim, if I can ask a question, so you're saying you can replace the plug on the end of a extension cord? Am I hearing that correctly?
Yep.
Okay.
There's a place in the OSHA rules where it says, damaged cords have to be taken out of service uh, until repaired. And so the common interpretation of that by OSHA is that if you use a proper fitting to repair it, I think what's recommended is go ahead and cut out the damaged areas and put in a new plug. And we certainly did that around our shop a lot. If a 100-foot extension cord gets damaged in the middle, you cut out the bad section and put 2 new ends on, and now you got 2 50-foot extension cords. So the 2-prong plug, it doesn't have the ground option and should only be used indoors. Okay. And then there are ratings for your extension cords. And just when you're buying an extension cord, make sure you know what you're going to be using it for, what is the amperage rating of the tools that you're likely to be using, and make sure you have an appropriate cord, and they're rated based on the length and the amperage that they can supply. And that should be right on the packaging anytime you buy an extension cord. So check the tools that you're going to be using for amp load, and then get an appropriate cord. There are a few designations that are required. The only one specifically required under the OSHA rules is the S designation is required. I would also think, though, that it would be necessary to have the W rating for any cords you're going to be using outdoors. And that information is on the packaging, and it's also imprinted right on the cord. So I think at a minimum, you should have S and W ratings on your extension cords. And if this looks like the pile of extension cords in your truck, you might want to consider how you're storing them. Try and keep your job site clean and free of trip hazards as much as possible. Avoid running extension cords across walkways and doorways where people have to travel. Keep things neat. A big old pile of extension cord on the ground certainly creates a trip hazard. And grounding. There's 2 different requirements that OSHA has for electrical grounding. Okay, and right off the bat, they say the employer shall either use ground fault circuit interrupters or an assured equipment grounding conductor program to protect employees on work sites. So the assured equipment grounding program is a lot of complicated rules in there, and it's fairly difficult to follow and comply with the assured equipment program. The simple way to be in compliance is to use GFCIs on all of your equipment. It's easy, and you are instantly in compliance if you're using ground fault circuit interrupters. So we're going to talk more about the GFCI in a minute. A couple other miscellaneous OSHA requirements with respect to power cords is do not raise or lower tools by the cord or an extension cord. And your cords and tools should be inspected at the beginning of each work shift. Tools with a 3-prong plug must be plugged into 3-prong cords. Right there it says there's the reference number that allows extension cords to be repaired. 1926.404B13C, if anybody wants to look that up. And under the OSHA rules, and this applies to anything that you're dealing with, you have to follow the manufacturer's instructions for anything that you're working with. Not just electric cords, it applies for anything. If you're using a saw and you don't use it in accordance with the manufacturer's recommendation, you can be cited by OSHA for that. And they commonly issue those citations. It's one way. It helps keep their rule book simpler because they can't envision every single safety rule for every single piece of equipment that's out there. So they rely on the manufacturers of the equipment to provide the appropriate recommendations. And under the OSHA rules, you can be cited for failing to follow those manufacturers' instructions. Okay.
Jim, so connecting 2 extension cords together is a no-no.
Well, that's what I was getting ready to say and talk about. OSHA doesn't actually say that anywhere in the rules, but nearly every manufacturer of extension cord says it in their instructions.
Interesting.
And if it's in the instructions, then OSHA can enforce it because they have a standing rule under the OSHA regs that you have to follow manufacturer's recommendations for any equipment or products you're using.
So it's very similar to a fireplace and follow manufacturer's installation instructions instead of building code standards. Very good comparison there.
Yeah. So you've got to follow those requirements. And while I was preparing this little presentation, I went to Home Depot and I was just looking at labels on all the various extension cords and reading what they say, and they all say don't hook them together. If you need to work a further distance, get a longer cord. And the cords, as they increase in length, they also have to increase in diameter to provide the necessary power at that distance.
Just curious, Jim, on an extension cord, what gauge should people be looking at? Like you're running a 100-foot drop cord, what gauge wire should be in that 100-foot drop cord?
For a good normal use one's going to be 12 gauge. And that's going to handle, common hand tools. If you're running something larger, like an electric mixer or something, you may need a thicker cord. But yeah. 12 is a good all-round work cord.
Just for sake of curiosity, let's say that we had jobs that we needed a 150-foot drop cord or extension cord. That's my Southern lingo coming out there, but you know what I'm talking about. But if I was to step up and make a 150-foot extension cord, what do you think the gauge of that wire should be if I was making that? Because I would be buying the wire from electrical supply and putting 2 plugs on it.
Well, you need to first look at the equipment that you intend to use, find out what the amp draw is, and then select the appropriate diameter. I had a chart a few slides ago. Let me see if I can find it quickly.
No, this comes up because we use a lot of 220 spot welders at the shop, and you can't buy a 220 extension cord. We have to make those. So we get
Yeah.
a really hit to carry 220. That's a pretty heavy load. And then we put 220 plugs on each end of it. But on a 220 welder, spot welder, that's what you got to run it off of. It's an extension cord.
Yeah. Well, is my screen still sharing?
Yeah, I see it fine.
Yeah. So this is a chart I found that goes up to 100 feet. I know charts, for longer distances are available. I don't have instant access to one right now, but you'll just have to do a little bit of research to make sure you're getting the appropriate thing. All right, I believe we were on this slide. Okay. So again, follow all of the rules. All right, let's talk about the GFCIs because these are really handy and they will save your life. A GFCI, or ground fault circuit interrupter, can help prevent electrocution. If a person's body starts to receive a shock, the GFCI senses this and cuts off the power so fast that you will not get injured. So I think it's wise to always use a GFCI with extension cords. The GFCI can only protect downstream of the device. So the GFCI should be plugged in closest to the source and furthest from the load. And we'll talk about that more in a second. But basically, the GFCI monitors the current that's flowing on the hot wire and back on the neutral wire. And if there's an imbalance in that load, it assumes, okay, we've got electricity going off the ground somewhere, and it instantly shuts down the power downstream of the device. These are, they're required in any wet areas, like under the electrical code. You have to have them in bathrooms, on decks, around pools. They're just required in the house wiring, but there are also lots of portable GFCIs. And that picture there on the right is really what we should be using for our technicians, something like that. You can either, buy 100-foot extension cords with the GFCI built in, or you can use this one that gives you GFCI protection, and also, 3 outlets that you can plug tools or extension cords in. These are pretty handy. They will save your life. They're not very expensive. That device right there is like $30, and it's well worth it. It's well worth it. And if you just do it, you're instantly in compliance with the OSHA grounding requirements simply by using the GFCI. If anybody's seen my safety bag program or video, we include a GFCI in the safety bag for all of our technicians. This picture shows a extension cord with the GFCI built into it. Certainly that would be a good way to be in compliance. If every extension cord on your truck has the GFCI, you can't go wrong. It adds a little bit to the cost of the cord, but it may just well be worth it.
Okay, so Jim, would you see that the piece added into the extension cord or the pigtail like you see in your safety bag, which you feel is the better process for somebody to follow?
Well, I guess either.
I don't want to confuse you. I'm just really, this is real interesting.
Well, Either is going to be fine. Okay. If if you had the GFCI extension cord like you see in this picture, you can't forget to use it. You can't go wrong. If you simply only have this type of cord on your truck, anytime you plug in the cord, you're automatically going to be protected. Uh,
On
it's no hunting around. Oh, where's my GFCI pigtail? Oh, I left it at my last job. I'm going to go ahead and use my extension cord without it because my boss is
yeah.
going to
How
be
many
upset if I don't get this job done. So I think this is a great way to always be in compliance.
how many on a pigtail you can plug multiple extension cords in your pigtail? Am I right or wrong?
Yeah, you can.
How many is the maximum you've seen on a pigtail like that? 3?
3 is the most I've ever seen. But
Okay.
again, you've got to stay in compliance with the rating
Yeah.
of that unit. So, if you've got 3 powerful tools that you're trying to run, it won't handle it.
Yeah.
So use either the GFCI pigtail or an extension cord with it built in, because most of the time when we're using extension cords, we're outdoors, we're running up, along a ladder, up on scaffolding, across wet grass. Protect your people, use the GFCI. And that brings us to the end. And as I said in the beginning of this presentation, this isn't, the end all be all to all electrical safety, but it's some things you can do to help improve your safety culture, demonstrate to your folks that, you're committed to providing a safe work environment. And that's what we want to do. And you've just got to work safety into your culture and make it a part. So I'm going to stop sharing my screen.
You know,
I'm going
Jim,
to unmute everybody, see if there's any questions.
Jim, I think one of the things is over the last 2 months, I think we've all been seeing so much COVID, avoid this, avoid that related to COVID. And I think a lot of people are missing out on the basic safety stuff. They've kind of lost focus on it, if that makes sense to you. I think that's where doing a class like this is real helpful for people, because these are the things that just aren't at the top. Till somebody gets electrocuted, it's just like the helmet thing and everything else. When somebody gets electrocuted, that's when it catches everybody's attention.
Oh, for sure. Absolutely. And you need to establish a safety program in your business and just make it a part of your culture. And anything that you bring into your business new, it's going to be tough initially, but if you're talking about it and you're reminding your technicians about it often, eventually you will be successful. You will have a better company for it, and your technicians will be safer.
Just got to be a bitch about it. I'm serious. That's what
Sometimes,
you just got to be a bitch.
You have to let them know you're serious. That's really what it's all about. So, if there's no other questions, I hope you guys found this useful. Next week we're going to talk about PPE, personal protective equipment. I'm still kind of working on that seminar, but I have a feeling that's going to be more than one part. I try to keep these things down to around 30 minutes so that you can use the rebroadcast of it during your tech meetings and so forth. Just, toolbox talks for your technicians and so forth. So I hope everybody has a great day, and we'll see you next week on Tech Talk.
See you later, brother. Have a good
All right.
day, Jim.
Thanks.
Appreciate it.
Bye bye.